Yes, Sarah, take it away. Sarah.
Going to be present. Yeah, are you guys hearing me?
Yeah, we can hear you.
So this is 3E. I'm going to be uh, it's all about transferring machine vision techniques for waste sorting. So as before, it and sustainability efforts. So waste sorting plays a crucial role in efficient recycling and waste management. So that actually see an environmental impact. So to address the challenge above, we have the integration of machine vision techniques that offers promising solutions. By that I mean using advanced algorithms and image processing techniques, transparent waste sorting with unparalleled precision and speed. So we chose things that so that have the next slide. With the data sets, one, we have the waste classification it was published May 2nd, and also the garbage net dataset, and it's updated 4 months ago. So my friends will be elaborating more what's within the dataset and why we chose it. So calling upon Jared to take us through. Jared?
Yeah, good evening. We have two data sets. We have the waste collection data set, which was published on 2nd of May 2023, and we have the garbage image data set, which was published 4 months ago. So the waste collection data set, I provide the collections of 24,705 images of solid waste categorized into classes: organic and recyclable waste. This data set was restructured from the original version. And the original version, the link has been sent. It was from Calco. Then it was restructured to give the number that the figure I've just mentioned above. Yeah. So this data set, they performed a series of cleanups and cleanup operations, which was further explained in the data set itself, in the research study. Then another data set we have is we have another data set, which is the garbage image data set. So this data set was crafted specifically for researchers, and that's why we even chose it for our exploratory data analysis. So it was crafted for researchers diving into garbage classification via deep learning. So this data set has a collection of 2,527 images distributed among 6 categories. We have the cardboard, glass, metal, paper, plastic, and trash. So this data set is specifically for images. Specifically has images. So the challenges we encounter in data set is class imbalance. We observe a significant difference in the number of images per class, with some class having fewer samples than others. For instance, we can see like trash has only 137 images, while paper has 594 images. But the data set also has have solutions to these challenges, like resampling techniques, which addresses the imbalance by either oversampling the minority class. Then we also have data augmentation, which artificially expands the data set by applying transformations to existing images, creating variations while preserving the labeled information. So I'll call upon our next colleague to explain the EDA.
Yes, good evening. I'm on. And as my colleagues have already shared from the two data sets that we are going to be working with, we shall work with the cargo data set, which is the garbage image data set. As my colleague has said, it's more convenient for us because it has a good number of images from different wastes, and they are much more balanced compared to the waste classification data set. So, but to what I want to talk about more is the EDM, which is the explanatory data analysis. Basically, this is a technique or a skill that is used by data scientists and people doing machine learning to investigate and be able to summarize and clean up the data and understand the characteristics, the patterns, and the trends within the data. So basically, this process is done before the data set is available to the algorithms for training. Yeah. So we have to first clean up and understand which kind of data sets we are using. So before I go, I think yeah. So the main objectives, as I've already said, it's to clean up the data set, and it's also to understand more of the variables in the data set. And we also want to understand the relationships between the variables of the data set. Yes. And we did that by first working on our code, on our data set, and here is our code. First, we imported the different types of the libraries, and one of the libraries we imported is OS, which helps us basically to work with the operating system of our machine. And as you can see them, the CV2, and unfortunately we did not use the CV2 because our data is purely pictorial and it's more of it's only images, and and CV2 basically mostly works for the tabular kind of data. So we also imported the matplotlib. This one is basically useful for visualization, as we are going to see from the heat maps and the bar graph that we used. We also imported the Seaborn. This one is also basically for visualization and beautifying the visuals from the data, such as the heat maps and the like. So yeah, we also imported pandas. However, pandas is for tabular data, and ours unfortunately is not tabular data. So the first we wrote a function, and this function is basically for loading and preprocessing the images. Yeah. So as you can see, the classes, we define the classes and the target size, and then after loading our images from the different classes, then we have to call the function, as you can see def here. Yeah, so this one is basically for calling the function that we have stated here. And then from that, we moved on to calling our path to the data set. As you can see here, this is where our data set is located on our local machine. And then you load the data set from this function that you've called. And then here, we continue to see that we analyze the different, we display the different images from the different classes. And it also shows here the distribution. Here we are going, as we are going to see the heat maps, which are included in the slides, basically for better visibility. Yeah, that's why I put the heat map and the bar graph in the slides, as I will show at the end. Yes. So basically, this function calls for the images from each class of the data that will be of each class of the images that we have. Yeah. So the heat maps and the bar graphs are here. This is our bar graph. I just basically this is from our code. I just put it here, and it shows here the number of images that we have, and then here the classes that we have, which is recyclable, the non-recyclable, and the organic. Then here we showed our heat map is a bit of complex because unfortunately, since we do not have the tabular data, kind of having a heat map for the interpretation of the heat map is kind of a complex one, but this is what we came up with from our data set. I think that marks the end of our presentation. Thank you.